The Allais Paradox is a fascinating challenge to expected utility theory, demonstrating how people often make decisions that contradict traditional notions of rationality. Expected utility theory, developed by von Neumann and Morgenstern, assumes that when individuals face uncertain outcomes, they will choose the option that maximizes their expected utility, or, in simpler terms, they will make decisions based on maximizing their anticipated value. However, the Allais Paradox reveals that in practice, human decision-making often deviates from this logical framework, exposing the limits of rational models in describing real-world behavior. Maurice Allais, the French economist who introduced the paradox, crafted a thought experiment that vividly illustrates this deviation. Consider two decision scenarios. In the first scenario, you are presented with two choices. A 100% chance of winning $1 million. A 2, a 10% chance of winning $5 million, an 89% chance of winning $1 million, and a 1% chance of winning nothing. In the second scenario, the options change slightly. B1, an 11% chance of winning $1 million, and an 89% chance of winning nothing. B2, a 10% chance of winning $5 million, and a 90% chance of winning nothing. According to expected utility theory, a rational person's choice between A1 and A2 should be consistent with their choice between B1 and B2. If they prefer certainty in the first scenario, they should also prefer the safer option in the second. Yet in reality, many people prefer A1 in the first scenario, valuing the guaranteed $1 million, but choose B2 in the second, willing to take the higher risk for a potentially greater reward. This inconsistency, preferring A1 and B2, directly violates expected utility theory and highlights the paradox. At the heart of the Allais paradox is what we might call a preference for certainty. When presented with the option of a sure win, people often favor it, even if a riskier option could offer a higher expected payoff. However, when all choices involve risk, as in the second scenario, they are more inclined to take the bigger gamble. This behavior challenges the traditional rational model and exposes how human decision-making is influenced by psychological factors that extend beyond simple calculations of value. To make this clearer, imagine you're standing at a crossroads. One path leads to a guaranteed prize of $1 million, while the other offers a slim chance at $5 million, but also carries the risk of getting nothing. Most people would take the guaranteed $1 million, even though the other path has a higher potential reward. But now imagine that both paths involve risk. One path offers an 11% chance at $1 million, and the other a 10% chance at $5 million. In this case, people often prefer the riskier path with the higher potential payout, even though both options carry uncertainty. This shift in behavior reveals how people weigh certainty against risk differently, depending on the context. The Allais paradox isn't just a quirky thought experiment, it has profound implications for our understanding of rationality and decision-making. It shows that expected utility theory, which assumes that people will always make choices that maximize their anticipated value, doesn't fully capture how people behave in real-world scenarios. Instead, people exhibit risk aversion and a strong preference for certainty, especially when the stakes are high. This contradicts the idea that individuals always act in a perfectly rational manner to maximize their gains. Psychologists Daniel Kahneman and Amos Tversky developed prospect theory to explain this behavior. Prospect theory suggests that people weigh potential gains and losses differently, often giving disproportionate weight to certain outcomes. This helps explain why, in the Allais paradox, people tend to favor the certainty of A1 over the riskier but potentially more rewarding A2. When people see a guaranteed reward, they value it more than a probabilistic outcome, even when the math suggests they should be indifferent or even favor the higher expected payoff. The implications of the Allais paradox extend beyond individual decision-making into fields like economics, finance, and even insurance. In finance, for example, investors may shy away from high-risk investments, even if those investments have higher potential returns, preferring safer, lower-yield options because of their aversion to risk. Similarly, in the insurance market, individuals are often willing to pay a premium for the certainty that comes with transferring risk to an insurer, even if the expected value of that transaction is negative. This tendency to overvalue certainty reflects the psychological forces at play in the Allais Paradox. Moreover, the paradox brings to light the limits of rational models. Just as Gödel's incompleteness theorems in mathematics revealed that no formal system can fully prove its own consistency, the Allais Paradox exposes blind spots in rational decision-making frameworks. It forces us to question the applicability of expected utility theory in describing human behavior. People are not purely rational agents calculating probabilities and outcomes. They are influenced by factors like emotion, fear of loss, and the psychological comfort that certainty provides. The Allais Paradox also has philosophical implications. It invites us to reflect on the nature of rationality itself. If humans consistently violate the principles of expected utility in favor of certainty, does that make them irrational? Or does it suggest that traditional models of rationality are incomplete, failing to account for the complexity of human psychology? In many ways, the paradox reveals the tension between the rational and the non-rational in decision-making. It suggests that factors such as emotional responses and subjective preferences are just as crucial in understanding behavior as mathematical models of risk and reward. In conclusion, the Allais Paradox is not merely a puzzle to be solved, it is a window into the limitations of our logical frameworks. It shows us that while expected utility theory provides a useful tool for understanding decisions under uncertainty, it doesn't capture the full range of human behavior. People value certainty in ways that rational models cannot fully explain, and this has far-reaching implications for fields like economics, finance, and philosophy. By examining the Allais Paradox, we gain insight not only into decision-making but also into the broader question of what it means to be rational in a world filled with uncertainty. In the end, paradoxes like these remind us that human behavior is often more nuanced and complex than the theories we create to explain it.